Welcome to this session. In this session, we are going to explain how to find a linear combination of a vector in terms of the other vectors. So the problem one reads, if possible, write the vector W given by elements 1, 1, 1 as a linear combination of vectors in the set S1, which has three vectors, 1, 2, 3, 0, 1, 2, negative 1, 0, 1. So to solve this one, solution, we need to find I see we can call this vector to be V1, this one to be V2, this one to be V3. So need to find C1, C2, and C3 such that this vector W can be written as C1 V1 plus C2 V2 plus C3 V3. This is a definition of a linear combination of a vector W in terms of the three vectors V1, V2, V3. So let's replace. So W is 1, 1, 1. And then we have C1 is 1, C1, then V1 is 1, 2, 3, plus C2, which is this vector V2 is 0, 1, 2, and then plus C3, vector V3 is negative 1, 0, 1. So this is just by definition inputting in the values of V1, V2, V3, and the W given. Now, if we have a scalar, if you multiply by a vector, that scalar multiplies every element of the vector. So we'll have 1, 1, 1 is equals to C1 times 1 is C1, C1 times 2 is 2C1, C1 times 3 is 3C1, C2 times 0 is 0, or I can say 0 C2, C2 times 1 is C2, C2 times 2 is 2C2, plus C1 times negative 1 is negative, C3 times negative 1 is negative C3, and then 0 C3, and then C3. That's how we do scalar multiplication of vectors. And then the right-hand side, when we are adding vectors, we simply add corresponding elements. So we'll have C1 plus 0 C2 plus minus C3. That's the first element. Second element will be 2C1 plus C2 plus 0 C3. And then we have 3C1 plus 2C2 plus C3. And remember, this side is 1, 1, 1. So then now, for this equality to make sense, then it means that the first element on the left of this vector should be the same as the first element here. Second element on the left-hand side vector should be the same as second element on the right-hand side vector. Third element on the left should be the same as third element on the right. So this implies that C1 plus 0, C2 plus minus C3 is given by 1. And then this second one, 2C1 plus C2 plus 0 C3 should be the same as this second element on the left. And then 3C1 plus 2C2 plus C3 should give us this third element on the left vector. Now you see it has resulted into a system of three linear equations in three unknowns, C1, C2, and then C3. So what we do now, we solve this system of linear equations to find the value of C1, C2, and C3. Now the augmented form or augmented matrix now we use, let's call this one system star. We use Gaussian elimination or any other method that you like, elimination. Solve star. So let's write the augmented form of this system. So I'll have 1, 0, -1, 2, 1, 0, 3, 2, 1. And then we have 1, 1, 1. So this is augmented matrix of the system. Now, to solve this system, so we have 1, 0, -1, 2, 1, 0, 1, 3, 2, 1, 1. So we say row 1 to be row 1, because this is a leading one. Row 2, we expect this to be 0, but we use row 1 to correct it. So we say row 2 plus -2 times row 1, so that this will get 0 at this point. And then next one, row 3, will be row 3. And to get 0 here, we say plus -3 row 1. So that computation will lead us to 1, 0, -1, 1, 2 times 2 plus -2 times 1 is 0. 1 plus -2 times 0 is 1. 0 plus -2 times -1 is 2. And then 1 plus -2 times 1 is -1. And then this will be 0. 2 plus -3 times 0 is 2. 1 plus -3 times -1 is 4. 1 plus -3 times 1 is -2. Now this one is okay. This one is okay. So we say row 1 to be row 1, row 2 to be row 2, and then row 3 will be given by, say, row 3 plus -2, row 1. So that leads us to 1, 0, -1, 1, and then 0, 1, 2, -1. This would be 0, 0. 4 plus -2 times 2 is 0. -2 plus -2 times -1 is 0. So this is the leading, and this is the leading. So remember, this column is for C1, this for C2, this for C3. So that tells us that C3 is a free variable. C3 from this one is a free variable. So this means C3 is a free variable. So let C3, we say T, where T is any real number. So that tells us that now from this one, we have C1 plus 0 C2 plus minus C3 equals to 1. And then this other one tells us that C2 plus 2 C3 equals to negative 1. So from this one, it implies that C2 is given by minus 1 minus 2 C3, which will be minus 1 minus 2 T, because we have said let C3 to be T. Now from equation 1, this if you call this equation 1, this one equation 2, this is from 2. Now from 1, we have C1 equals to 1 plus C3, which is equals to 1 plus T. So this from equation 1. So therefore, the solution is C1 is equals to 1 plus T. C2 is given by minus 1 minus 2T. And C3 is given by T, where T is any real number. So this is a case whereby we have an infinite number of solutions. So if we let T to be 1, then the solution will be C1 will be 1 plus 1, which is 2. C2 will be minus 1 minus 2 times 1, which is minus 3. And C3 will be just 1. So W will be given by C1, which is 2V1. C2 is minus 3V2, and then plus V3 times 1. So that is a possible linear combination of the vectors given by set S1. So that's how we find solution for that. Thank you.